Okay, in this math 2, we're going to do 51, 50, what is it? 3, 54, 56. Okay. The first one should not take too much time, but we'll see what happens. So plot triangle, oh, this is going to take a while. So plot triangle ABC with vertices 0, 0, A 0, 0, wait, this is totally wrong. Why are these in the wrong spot? A is 0, 0, B is 3, 4, and C is 3, 0. What? Okay, these are totally off. Okay, I think I should have probably actually checked before I did it. Okay, I'm going to have to come back to 51 in another video. Alright, 53 is where we're going to go to next. The area of the triangle at the right is 25 square feet. Determine the value of the height. Calculate the perimeter of the entire triangle. Show all your work. Oh boy. Really? Okay, fine. Okay. So the area of the triangle is 25 square feet. So that means area of the triangle is equal to base times height divided by 2. So we have area of the triangle is 25, right? Because it gives us the actual answer for the area. We know the base is 10. 10 times, we don't know the height. 10 times height divided by 2. All right. So let's see. We have... put it over 1, so we have times, I guess we can make common denominators, times 2 times 2. So we have 50 over 2 is equal to 10 times h divided by 2. So that means 50 is going to be equal to 10 times h divided by 10 on both sides. We get the height is equal to 5. All right. So the height is 5. Yay. Alright, so now we need the perimeter. Okay, so the perimeter means that we need to find x and we need to find y because we need those two sides. So for this part right here, we have, let's see, what do we have? Oh, we're just going to have to do Pythagorean theorem twice. Okay, so we have leg, hypotenuse, right? Because it's across from the 90-degree angle. So this is the hypotenuse. So leg, hypotenuse. So that means we have 4 squared plus 5 squared equals x squared. For this right triangle. And so that gives us what? 16 plus 25 equals x squared. I have no idea what 16 plus 25 is. There's no way. 25 plus 16. 41 equals x squared. Take the square root of both sides. So we have 40. The square root of 41 equals x. Okay. All right. Not very informative, but, you know, it is what it is. Which is actually somewhere around 6.4, actually, if you really wanted to know. Square root of 41 is around 6.4. Okay. For this one, we have leg, hypotenuse also. So we have 6 squared plus 5 squared equals, we'll call it y squared. We have 36 plus 25. 36 plus 25 is 61. Well, 61 is not perfect either, so that pretty much tells us the square root of 61 is going to give us our y. And, okay, so this is going to be the square root of 61. X is going to be the square root of 41. And we need to put our perimeter together. Okay, so we have a perimeter of, let's see, square root of 61. Sorry, square root of 61 plus square root of 41 plus 10. All right. Well, this would be much easier if I show you what it's going to look like on the calculator because it should come out to a weird decimal. First of all, you cannot put 61 and 41 together. If in the next line you write something like the square root of 102, that is not correct. Okay, and I will prove that to you right now on the calculator. All right, so if I give you, zoom in for a second, the second square root of 61, right, and I do plus the second square root of 41, I should get something like that. Right, 14.21. If I do the second square root, and some of you want to do this, I don't know why, 61 plus 41, and then do like 102, because you think somehow those things belong together. square root of 102 is 10.09. That is not the same thing. So you cannot tell me that square root of 61 plus square root of 41 is the square root of 102. They're just not the same. But I can still calculate the perimeter. So I have second square root of 61, right, plus second square root of 41, plus 10, which was the bottom of that triangle, and that gives something around 24.21. So I'm going to come over here, and I'm going to write something around 24.21, or if you want to leave it exactly like the top part, I'm fine with that too, and this was in feet, right? Okay, sorry for the sloppy handwriting. I'm getting tired. 54. Are these triangles congruent? If so, use a flowchart to show how you know. If they are not congruent, explain how you know. Okay, well, I'm going to tell you they are right now, and you should have enough handle on it to be able to identify what it is. So your flowchart is going to be one of the simple ones, right? You have sides labeled with numbers, so I should see I should see the start of something that looks like this. Okay? That's what it should look like. Okay, and every single bubble should have a reason inside. I'm sorry, every single bubble should have a statement inside and a reason on the outside. You should be able to tell me what this is by now. All right, 56. So don't tell me that it's not. I'm telling you that it is, and you better do it correctly. For each of the triangle below, solve for the variable and answer the questions. Solve for x. What kind of triangle is ABC? Be specific. Okay, well, x looks like, well, it'll look like that, so I can flip it around. Since you have two sides that are congruent, that means this angle down here and this angle down here are both going to be the same. So that means this is x also, which makes your life super convenient because now you have all three angles. By the way, this is the base angles theorem for an isosceles triangle. That's the one we did, I think, 2 homeworks ago or 3 homeworks ago. So you have 2x plus x plus x. You have 3 angles all equal to 180, and I'm sure you can solve for x like that. Now here, it's the same thing. You have an isosceles triangle, so that means base angles must be congruent. So this must be 71 degrees also, and that makes it super easy for you because now you have a linear pair between 71 and y, and you should have an idea to have solve for y. Right? That was 56. What kind of triangle is shown in the figure? Isosceles triangle. Y. Okay. All right. Sorry about 51. I'll do it in the next video. I gotta get the... Actually, no, we could just do it. We can do it in this one. I'm just gonna need graph paper instead. I don't want to stop and make another video. So ignore that because that's not what it is. Okay, we're gonna do this on regular graph paper. All right, we have to draw our x and y axis. And hopefully this doesn't get too crazy. Dilation sometimes can get way big and then it can get a little ugly. X and Y. Alright, so we're going to plot our points. A with 0, 0. B with 3, 4. Here's A, here's B. And then C is 3 and comma 0. 3 and 0. Didn't we do this in class? Alright, well, whatever. I could have sworn we did something like this in class. Maybe it's on the next homework assignment, or next lesson. Alright, so here's our normal triangle. It's nice because it's a right triangle. And so what we're going to do is we're going to blow this up. Use the origin as a point of dilation, right? So we're going to pretend there's a flashlight right here, and it's going to beam the flashlight in this direction, and enlarge it by a scale factor 2, or basically 2 rubber bands. So if we take A to B, right, we're going to make it bigger again by 2 rubber bands. So this is, if we just take it to A to B, that's 1 rubber band. We want to make it 2 rubber bands. So it's going to be somewhere over here, I think, right? From here to here, here to here. Okay, so that's going to be B prime. All right. And then from A to C, and then I'm going to do another rubber band. So the same distance here, I'm going to blow it up twice, right? Same distance here, same distance here, same distance here, same distance here. So that means C is going to be right there. I'm going to blow, so that's going to be blown up. And then, so I did this one is the same as this one's the same as that. This distance is the same as this distance. Distances here has to be, so this is going to be half of this distance up here. So we're going to see what that, hopefully that looks like about half the distance. Okay, so we have a small triangle and then a larger triangle. So now we need to check, right? Because I think that's what it's asking us to do. What are the side lengths of the original triangle ABC? What are the side lengths of the enlarged triangle A prime, B prime, C prime? Calculate the area and perimeter of A prime, B prime, C prime. So the side lengths from A to C would be 3. From B to C would be 4. That should be easy to do. The side lengths from A to C is 6. The side length from B to C is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so doubled. That's good. So now we just have to verify this part right here. We have to verify that that part doubled too. So 3, 4, and then we need to find this. So since it's a wonderful right triangle, then we can do Pythagorean theorem. This is your leg, this is your leg, this is your hypotenuse, right? So 3 squared plus 4 squared is going to give you AB squared, because AB is the side that we want. So we have 9 plus 16 equals AB squared. So 25 equals AB squared. So if we take the square root of both sides, we get 5 is equal to AB. So now I know for sure that AB is 5. Right? Because I'm not going to count on the slant, because that would be like 1, 2. That doesn't make any sense. You don't count on the slant. All right? So now we have 6 and 8 for the large green one. Right? 6 and 8. So we're going to do the same thing again. We have 6 squared plus 8 squared is going to be A to B prime squared. Right? Because that's what we want to get to. 6 squared is 36. 8 squared is 64. AB prime squared. 36 plus 64 is, I have no clue. 100. Okay. 100 is AB prime squared. So if I take the square root of both sides, I should get the square root of 100 is 10, not 50, because I'm not taking the half of a number, because obviously half of 25 is not 5. So that gives me A to B prime. So that means this entire distance right here is going to be 10. All right, so that takes care of that, because you should be able to answer what are the side lengths of the original triangle ABC, what are the side lengths of the enlarged triangle A prime, B prime, C prime. Let's calculate the area and perimeter of A prime, B prime, C prime, right? So perimeter should not be a problem. The area of any triangle, again, was base times height divided by 2, so you should be able to work that in there. And the perimeter is just add up all the sides. All right, that was 51, 50, and then we did the rest of them, so we're good to go. Sorry about it being backwards, but there you go. And I will see you guys later.